Hi class, welcome to another lesson. Today we are on 7.3. This is day 2 of our notes on 7.3. We're solving equation using quadratic techniques. So what we're doing here, class, is we're still getting x all by itself. We're isolating x. These aren't quadratic functions. Some of these are polynomial functions. Some of these aren't polynomial functions, but we're always solving them using quadratic techniques. So on this first one, going back to chapter 3, or chapter 5 rather, when we had to solve these, whenever you saw 4 terms, what we had to do is we had to factor by grouping. So that's what we're going to do here. Whenever you see 4 terms, think of factoring by grouping. So take something that is similar out of those two. What's the GCF of those two terms? It would be x squared. So then what do we have left over? We have an x and a negative 3. And now we're going to take out the GCF of these two terms. What is similar in those two? The positive 7 would be. If you take out a positive 7, you're left with x minus 3. That equals 0. So now that we have that, we now have 2 different terms, right here and right here. What is similar in those 2 terms? Hopefully you see it's the quantity x minus 3. So you could factor that out in front, and then what do you have left? After you've taken out this x minus 3, you have this left, x squared, and after you've taken out the quantity x minus 3, you have this 7 left, and it's a positive 7. So then you get the quantities x minus 3 times x squared plus 7. If you wanted to check your work, you can just FOIL these 2 binomials, and you would get right back to where you started with. So now we're not quite done yet. In chapter 5 we were done at this point, but we want to solve. So let's get x all by itself. So let's set this equal to 0, x minus 3 equals 0, and let's set this equal to 0. X squared plus 7 equals 0. So this is a degree of 3, so we should get 3 answers for this one, 3 different solutions. X equals a positive 3. There's one of them. X squared equals a negative 7. So when we square root both sides, x equals plus and minus I square root 7. We can't reduce the square root of 7, but we can take out this negative 1 because the square root of a negative 1 is an I. So there's our 3 answers, x equals 3 and x equals plus and minus I squared root 7. Why don't you guys pause the video and try number 2 on your own. Number 2, you should have factored out an x squared term from these first 2. So then you would get x squared times the quantity x minus 3. On this one, because this is a negative sign, factor out a negative 4x. So here's our second 2 terms. Factoring out a negative 4, sorry, not a negative 4x, just a negative 4. What are you left with? You are left with an x and then a minus 3. 12 divided by a negative 4 is a negative 3. If ever you're stumped at this spot, you could always check your work. Distribute this back. A negative 4 times x is a negative 4x. A negative 4 times a negative 3 is a positive 12. So you're right back to where you started with. You haven't changed anything yet. Now that we have this, we see 1 term here and 1 term here. So hopefully when you did this on your own, you took out the x minus 3 term, that whole quantity. And then you're left with an x squared and a negative 4. That equals 0. If you stopped right here and said both of them equal to 0, that's just fine. What you could have done as well is you could have broken this up, because this is the difference of 2 squares. So I'm just going to bring this x minus 3 down. And now this factor down to x minus 2 times x plus 2. And that equals 0. So now you could set all 3 of these quantities equal to 0. X minus 3 equals 0, so x equals a positive 3. There's one of your answers. X minus 2 equals 0, so x equals a positive 2. And x plus 2 equals 0, so that means x equals a negative 2. So there's your 3 answers for this one. X equals 3, and x equals plus and minus 2. At this point, if you were to have set this equal to 0 and this equal to 0, you still would have got the right answer, because you would have square rooted both sides in this one, so you would have still got x equals plus and minus 2. So either way, there's your answer. Alright, the next 4 or 5 problems very similarly done, and they're done differently than the first two. The first two, there was 4 terms, so we had to factor by grouping. This one, we're going to factor the traditional way where we form 2 different binomials. However, it becomes very different than what we're used to because we see fractional exponents. So this becomes very, very different. So watch very closely. What we're going to do is we're still going to form 2 different binomials, which is what you're used to doing. Now, you're used to going x times x. But remember, x times x is x squared. When you FOIL first times first, x times x is x squared. And we don't want x squared, we want x raised to the 2/3. So class, here's a hint. The exponent that always goes right here and right here is always this middle exponent. So it's going to be x raised to the 1/3 times x raised to the 1/3. X raised to the 1/3 times x raised to the 1/3. Because watch what happens when you FOIL. You're going to multiply the first times the first. So x raised to the 1/3 times x raised to the 1/3. With common bases, you add their exponents. So 1/3 plus 1/3 is x raised to the 2/3. And that's exactly what you see right here. So just as a shortcut, you can always have the first term in the binomials as having an exponent as the same as the I hope that makes sense. Hopefully after we do enough practice problems, it'll just become second nature. Now, you're used to factoring this 5 to get you a -6 right here, so that doesn't change. You're going to have a -5 times a -1. Because a -5 times a -1 is a +5. Why don't we just FOIL this out really quick so you can see it. X to the -1/3 times x raised to the -1/3 is x raised to the 2/3. Here is a, going from the outside, a negative x raised to the 1/3. Here's the inside terms, a -5x to the -1/3. And then the last times the last, a -5 times a -1 is a +5. So now combining like terms, we have x raised to the 2/3, -1 x to the -1, x to the 1/3, and a -5x to the, this should be a +1/3, is a -6 x raised to the 1/3. And then you have your +5. Which, as you can see, is the exact same thing we have right here. So you could always check your work on these ones if you just FOIL it down again. But now, our directions are to solve. So once we've factored it correctly, these equal 0. It equals 0. So that means each of these factors equals 0. X raised to the 1/3 minus 5 equals 0. And x raised to the 1/3 minus 1 equals 0. Now solve. X raised to the 1/3 equals 5. Now we have to get x all by itself, so we have to get rid of this exponent of 1/3. So how do we get rid of that exponent? We got to think about what's the multiplicative identity, which 1/3 times 3 gives our identity of 1. When you have a power raised to a power, you multiply these, so you just get x raised to the first, which that's what we want. X to the first is what we want. If you cube the left side, you have to cube the right side. So 5 cubed, 5 times 5 times 5 is 125. There you have one of your answers. You're going to have another one. X raised to the 1/3 also equals a +1. And the same way you cube both sides, you're going to cube both sides on this one too. Because x raised to the 1/3 raised to the 3rd, you'd multiply these two and just get x to the 1st. You have 1 cubed, 1 times 1 is 1. And there you have it, class. These are your answers. If you ever want to check it, you always could. X equals 125, so you can put 125 in right here, raise it to the 2/3. You can put 125 in here, raise it to the 1/3 and multiply it by a -6, and when you add these 3 terms, you should get 0. Same thing if you were to use the number 1. So it wouldn't take too long to check those in your calculator. Certainly feel free to do that if you'd like to. All right, next ones. Once again, you're going to form two different parentheses. Now we're always used to going x times x, but this time you're going to raise it to the power that's the same power on your middle term. So x raised to the 1/2 times x raised to the 1/2. Because x raised to the 1/2 times x raised to the 1/2 is x raised to the 2/2, which is 1, which is exactly what you see right there. Now we got to think of factors of 10 that give us a -3. That would be a -5 and a +2. -5 times +2 is -10, and we'd have 2x to the 1/2 minus 5x to the 1/2 is a -3x to the 1/2. So we have successfully factored it. Now we are going to solve. So x raised to the 1/2 minus 5 equals 0, and x raised to the 1/2 plus 2 equals 0. Solving for x. The first thing I'm going to do is add 5. So x raised to the 1/2 equals 5. Now, just like in the last one, that multiplicative identity, what do you have to raise 1/2 to, x to the 1/2 to get x raised to the first? Well, when you multiply fractions, you just multiply by the reciprocal of 1/2. So 1/2 times 2 is x raised to the 2/2, which is the same thing as x to the first. And that's what we want, is x to the first. If we square the left side, we got to square the right side. So 5 squared is 25. There's one of our answers. Our other one, x raised to the 1/2 equals a -2. Now we have to square both sides to get rid of that 1/2. A -2 times a -2 is a +4. So x equals a +4. Now here's where you have to be very careful, guys. We could also get extraneous solutions as we solve for this. So this x equals 4, if you were to check it back up top, if you were to put 4 in here and 4 in here, you would not satisfy the equation. You would not get a 0 equals 0. This is what we call an extraneous solution. You did everything mathematically right, but it simply does not work. And here's the way you identify that, class. If ever you square a negative number, it will not work. You square this -2 to make it a +4, this is extraneous. So as a hint, as we go on in our notes, when you square a negative number to get a positive number, that one is extraneous. So this one, you only get one solution. It's x equals 25. If you're ever uncertain of yourself about whether it's an actual solution or extraneous, you could always check your work just by substituting it back up top here. It wouldn't take you more than 30 seconds, so to give you that peace of mind, it might be worth it. Number 5. First of all, we need a 0 over here on this side. So let's subtract that 7. So x minus 6 square root x minus 7 equals 0. Now on number 3 and number 4, we had it in exponential form. They weren't in radical form. So let's change this into exponential. This is the second root of x raised to the first. So this becomes your numerator, and this becomes the denominator. So now we have x minus 6 raised to the 6x raised to the 1/2. Does everyone understand what I did here? I took this square root x, and I made it into x raised to the 1/2. Subtract 7, that equals 0. Now we're more familiar with this part, so we can now factor this. Form two different parentheses. It's going to be x raised to the 1/2 times x raised to the 1/2. Factors of a -7, that gets you a -6, would be a -7 and a +1. Now we have these two binomials. Let's set each of them equal to 0. X raised to the 1/2 minus 7 equals 0, and x raised to the 1/2 plus 1 equals 0. So now we have x raised to the 1/2 equals 7. So now if we square both sides to get rid of that exponent of 1/2, we get x equals a positive 49. There's one of our answers. The other one, x raised to the 1/2 equals a negative 1. So now when we square both sides, hopefully you see this, x equals 1, but this is extraneous because you just squared a negative number. So that one does not work. Our only answer is x equals 49. Next one, why don't you guys try this one on your own. Pause the video, please. Let's see what you come up with on this one. Once again, hopefully you change this into exponential form, which is x raised to the 1/2. The square root of x is the same thing as x raised to the 1/2. So x plus 6x raised to the 1/2 plus 9 equals 0. With this, form two different parentheses, equaling it to 0. X raised to the 1/2 times x raised to the 1/2. Factors of 9, that gets you a positive 6. 3 times 3 is 9, and 3 plus 3 is 6. So there we have it. There's our two binomials. Let's set both of them equal to 0. X plus 1/2 plus 3 equals 0. X raised to the 1/2 plus 3 equals 0. As you can see, the binomials are exactly the same. So we'll get the exact same answer. X raised to the 1/2 equals a negative 3. Squaring both sides, this negative 3 times negative 3 is a positive 9. But we just squared a negative number, so this solution is extraneous. And then because these binomials are exactly the same, x raised to the 1/2 equals a negative 3. Squaring both sides, x equals a positive 9, also extraneous. So what is our answer for this one, class? What does x equal? There isn't such a number. X is no solution, or the empty set. Either one of those I'll accept on a test. Kind of crazy. There's an infinite number of numbers in our universe, and not one of those numbers you could put here and here to satisfy this equaling 0. There's not one. So we have no solution. Last one, number 7. A little bit different. Just seeing the square root, or x raised to the 1/2 power. Now we have 3/2, but we do know our process, so hopefully this won't be too difficult for us to tackle. We have x and x. Remember how you always raise it to the exponent that's on our middle term, or our b term. So it's x raised to the 3/2 times x raised to the 3/2. Factors of a positive 8 that get us a negative 9 is a negative 8 times a negative 1. There we have it, our two binomials. Let's set each of them equal to 0. X raised to the 3/2 minus 8 equals 0. X raised to the 3/2 minus 1 equals 0. We're going to add 8 to both sides. X raised to the 3/2 equals 8. Now, class, we want to get x all by itself. So what is the multiplicative identity of 3/2? You simply multiply by the reciprocal, which is 2/3. 3/2 times 2/3, a power raised to a power. You multiply these, and you get 6/6, which is the same thing as x raised to the first. What you do to the left, you must do to the right. So raise 8 to the 2/3 power. You can do that in your calculator, or you can do that in your head. This is the same thing as the 3rd root of 8 squared. Change it into radical form. So now, what is the 3rd root of 8? You can take a 2 out, because the 3rd root of 8 is 2, and then it's 2 squared. So x equals 4. If you didn't want to do this part right here, you could just put 8 raised to the 2/3 in your calculator, and once again, you would get 4. Do that as well. There's one of our answers, x equals 4. The other one, let's find it. X raised to the 3/2 equals 1. In the same way that we put both left and right sides to the 3/2 power, we're going to do the same thing on this one. And now we get x raised to the 6/6, which is x raised to the first, equals 1 to the 2/3, which is the same thing as the third root of 1 squared. What is the third root of 1? 1 times 1 times 1 is 1, so the third root of 1 is 1. So x equals 1, and then we have to square it still. And 1 squared, 1 times 1 is 1. Two answers on this one, x equals 4 and x equals 1. Our assignment is going to be a worksheet. You're going to have several problems where you have to solve by grouping, and other ones where you have fractional exponents. Remember that whenever you're factoring, your first term is always going to be raised to this exponent, x raised to the 1/2 times x raised to the 1/2. And then you should be good to go from there because you guys are very familiar with factoring that third term in these two spots. So we have that worksheet. Be sure to let me know if you have any questions when you come into class tomorrow.